Thank you, Christian. It's okay? Okay. So today I'm talking about IPv6, MPLS, and segment routing. So, okay. So I'm talking about the service provider infrastructure, how to configure the service provider infrastructure to use and to provide IPv6 service. But more than this, if service provider backbone are ready to use an IPv6 control plane, and how to prepare the infrastructure for this migration. So my name is Nicola Modena. I'm working as a network architect. Oh, okay. From 25 years now, so this is my field in service provider and large enterprise. So first of all, why IPv6? If we follow, it's okay? Okay. It's we listen to IPv6 promoter, IPv6 will solve all our problem because it's efficient, secure. It's not just a bigger address space, but sometimes we fall in what we call layer 8, 9, and 10 solution. So there is so political and economical interest in pushing this technology. So I want to point out that I'm absolutely in favor of an IPv6 adoption, but this don't mean that I'm against IPv4 or against innovation. In my consulting activity, I found quite often strange infrastructure with a lot of confusion, where the fix become always a permanent solution. So in that case, you have three choices. So the first one is that if you are able to manage your infrastructure, and we are happy with that, you can go in that way. Or the other option, it's believe in PowerPoint. So maybe adopt the latest AI agent, but the problem in that case is that probably you fall in the garbage in, garbage out loop. So if your infrastructure is not ready for that, you will have also problem. So this is my advice always, is to simplify the infrastructure and also remove all the unnecessary thing and also be ready for an IPv6 infrastructure. So end of the political part, now go through the technical part. So MPLS. MPLS is the reference technology in the last 25 years in the service provider backbone because it's efficient, it's flexible, and really mature technology. And during all these 25 years of evolution, we have two big constants. The first one is the data plane. So the MPLS encapsulation remained the same since the beginning. The other big constant, it's the BGP, multi-protocol BGP, where all the services are signaling. So layer 3 VPN, pseudo-wire, EVPN, multicast service. What has been changed in the last year is the migration from BGP and RSVP to segment routing. With LDP, you have your router that advertise the mapping of the local destination to label to the neighbor, and the MPLS packet just follow the IGP best path. And while with RSVP, you are able to create some traffic engineering solution. Now, almost all these functions are available in segment routing. But segment routing also does not change just the signaling of the label, but also how labels are used. Because with LDP and RSVP, usually you have one or two labels bind to the packet, And the forwarding, every hop, there is the router that swaps this label based on the local state of the router, while with segment routing, this information are directly pushed in the label stack. So all the information, all the state are moved from the core network to the label stack. So this change the core network, simplify the core network, and increase the scalability of the solution. So what is segment routing? Segment routing is directly the IGP that advertises the label, and so ISIS or OSPF, and there is a new concept of global label. So the value of the label is unique in all the MPLS backbone. This is very useful for troubleshooting or for observability. And also knowing all this information is very simple to create some traffic engineering path. So this is great advantage of segment routing. Another important thing is that segment routing might coexist with LDP and RSVP. So it is very useful for the migration, or if there is some service that are not available on segment routing, like multicast, because there is not yet a multi-vendor solution for multicasting segment routing. So back to the IPv6 part. So this is a configuration of segment routing. In this case, I'm using ISIS because it's a multi-topology IGP, so he can manage IPv4 and IPv6 address, and I add the configuration of segment routing to the IGP. So I define the global label range, and I give an unique index to the device in this label range. So in this case, I have this IP address binded to the loopback that is usually associated to the index. So this information is then distributed with the normal ISIS update to all the network. So all the router in my MPLS domain can get the value of the label to use to forward the packet to this destination. In case I have a dual stack router, so I have an IPv4 and IPv6 address on my loopback, I have two indexes. I have the index for the IPv4 and the IPv6 index to the IPv6 address. Why use two labels? Because this helps the router that decapsulate the packet to understand if the content is IPv4 or IPv6. And then, if I have a single stack IPv6 only router, I have just the IPv6 index. What is important in this slide? If you look at that, I move the configuration from a single stack IPv4 to a dual stack to an IPv6 only configuration, just changing one line of configuration. So the migration is really simple, okay? On the interface, I can do almost the same. So if I'm using IPv4 unnumbered interface and IPv6 link local, also in that case, I can move the configuration from an IPv4 to an IPv6 configuration just in really simple, just a couple of lines of configuration, because the forwarding is performed with MPLS packet. Also, in my activity, I found quite providers that use a dual stack solution. So they have, for example, OSPF and BGP for the IPv4 control plane, and then they had ISIS for the IPv6, and then also a multi-protocol BGP over IPv6 session, so a complex solution. My advice is always to use a single stack solution. So this is either IPv4 or IPv6. Using a single stack solution is simpler use less resource and also is easier to manage and to secure. And obviously must be able to provide both IPv4 and IPv6 service. So let's try to analyze if we can do that with an IPv4 only configuration. So this is a typical single stack IPv4 MPLS configuration. So we have IPv4 MPLS with segment routing or OSPF, ISIS, LDP, RSVP, whatever, no problem. And multi-protocol BGP over IPv4 section. So all the next hop are IPv4 address. So we can run all usual MPLS service, and to provide IPv6 service, we need to use 6PE and 6VPE. This is a really old solution. It's almost 20 years that this is available, and it's really used in most of the service provider backbone. So 6PE. 6PE, to create a 6PE solution, two problems must be solved. The first problem is that in BGP, the next hop, the prefix and the next hop must have the same address family. So an IPv6 destination, an IPv6 prefix must have an IPv6 next hop. To solve this problem, it is possible to map the IPv4 next hop into an IPv6 address, because there is no problem. The IPv6 is bigger, so this is solved. The other problem is to identify the content of the packet, of the MPLS packet, and IPv6 packet. And there are different solutions based on your allocation schema. The usually solution is to use IPv6 explicit null label, that is a reserved label, label 2, that identify the packet as an IPv6 packet. So in our backbone, we have a PE with two destinations, an IPv4 destination and an IPv6 destination. This router advertises to the route reflector the two prefix, the IPv4 prefix with the IPv4 next hop, and the IPv6 destination with the next hop, IPv6 with an IPv4 compatible address and the label 2. So the route reflector distributes this information, and if our PE want to send traffic to this destination, just encode the IPv4 packet with an MPLS label corresponding to the IPv4 next hop, and the IPv6 packet with the label 2 and the same next hop destination. So the packet goes through the backbone, and the router that performed the decapsulation recognizes this packet as an IPv6, this is IPv4, and forward based on the correct routing table and the correct encapsulation. So no problem on that. Let's try to analyze the solution with an IPv6 only, with a single stack IPv6 solution and MPLS. So I have an IPv6 as address and MPLS with ISIS and segment routing, because no one is investing in OSV3, LDPv6, RSVPv6. So the solution must be ISIS and segment routing. And also, multi-protocol BGP now is over IPv6 section. So all the next hop are IPv6 address. So I can run all my MPLS service, and I need something like 4PE and 4VPE for IPv4 service. The problem here is that there are now there are few solution technology to provide IPv4 service over IPv6 only infrastructure for the consumer. But the enterprise still use IPv4, so I need something really reliable and flexible to create this solution. So 4PE. 4PE exists, is currently a draft. There are now the release 8. And to create 4PE, the problem are the same. So we have the problem of the next hop, but now there is a standard that permit to use IPv6 next hop for the IPv4 prefix, and also the identification of the packet content as IPv4. In that case, there are some options, and the draft proposed to use IPv4 explicit null or use DPI. So let the NPU identify the traffic as IPv4 or IPv6. So I try the draft. Some vendors are different default and use different solution. I ran some tests in my lab, and I found that the solution based on DPI, so let the ASIC to recognize the content, it is the more reliable. So the solution for VPE, so is to use BGP IPv4, IPv6 prefix with IPv4 prefix with an IPv6 next hop, and no label, no special label for that. So the solution in that case is that my PE with two destinations, an IPv4 and IPv6 destination, just advertise to the raw reflector the two prefix with the IPv6 next hop, and the source router that want to send traffic to this destination just encode the packet with the IPv6 the label that correspond to the IPv6 next hop. So easier than the previous one. So now that we understand how 6PE and 4PE works, let's try to migrate from one configuration to the other one. So this is my existing infrastructure, IPv4 infrastructure, so my raw reflector and the prefix that created the 6PE solution. If I run ISIS and segment routing, I just add to the PE the IPv6 address and the new IPv6 index. So just with one line of configuration, I can enable the IPv6 component. So I add the IPv6-only raw reflector, and then when I enable also in IPv6 the source PE, I have the two advertisements. So just changing the route preference between the two control plane, I can move the service from an IPv4 control plane to an IPv6 control plane without service interruption. Okay, so simple. It's really easy, but probably we have worked a lot to create this environment. We need to migrate to ISIS probably and enable segment routing. And most important, we are using PowerPoint. Okay, so there are some problems. It's not so easy. For example, the first problem is EVPN. In EVPN, I have some information. In some BGP message, I have encoded the IP address of the router inside the message. So when I configure an AVPN service, I need to select between the IPv4 or the IPv6 control plane. So there is no interoperability between the two protocols. So I need something like a gateway function that translates this type of message. This is not, there are some vendors that start supporting that. And also, it's important that, for example, type 4 is used for multi-homing. So also layer 2 service doesn't work in this case. So it's critical, this problem. The other problem, big problem, is multicast, because multicast it's a mess. There is still no support in segment routing. You still need to use MLDP or RSVP or an external controller to create the multicast forwarding path. And also there are now 30 different profile in BGP. So good luck. Okay. A very useful architecture in that case is a seamless architecture. So if you are, for example, a greenfield infrastructure, you can work creating this infrastructure as an ipv6 only, and the border router for this region that act also as a route reflector can translate or hide all the ipv6 part. So this new infrastructure are completely transparent to the, for example, for the at the ipv4 core. Okay, there are an upcoming technology. This is the MPLS encapsulation that, as we can see, have been seen. Sorry, it's almost changed in the last 25 years. But now there is a new proposal about SR-V6 that propose to change also the data encapsulation. The first release, it's encode the equivalent of the MPLS label, the segment identifier or instruction. There are some different name on that. Directly in the, first of all, SR-V6 proposed to use ipv6 packet instead of MPLS packet. So this is the big change. So all ipv6. And encapsulate the packet inside an ipv6 packet. And encoding the equivalent of the MPLS label inside the ipv6 destination address, because it's bigger, so you can encode some instruction inside the ipv6 destination. The first release is not efficient because the ipv6 header it's bigger, and also segment routing usually use a lot of label, so there is an overhead that created a new version based on microseed, where there are more instruction or more label in the same instruction. But this requires some new hardware to perform this information. So usually SR-V6 require new hardware, not just new software for that. So anyway, with SR-V6, the control plane is ISIS and multi-protocol BGP over ipv6 address. So if you follow my instruction, you are ready also for an SR-V6 migration. Okay, this is very nice reading. The first one, it's Meta, Facebook, that is removing all the IPv4 addresses for the infrastructure, from the infrastructure, so they are using an IPv6 control plane with segment routing and MPLS. Is a good presentation. This is a presentation about the hardware, the ASIC, how ASIC work. It's really interesting, and how they modified the ASIC flow to create compatibility for the SR-V6 encapsulation. And the other one, and the last one, is an experience about migration to SR-V6. Okay, use case for an IPv6 control plane. The first one is a large service provider backbone, so where private IPv4 are over and they need a more address space. The other one is large SAP merge, when the problem is usually overlapping address space, and new implementation, but where there is a big pressure for an IPv6 adoption. Okay. Okay, my advice on that: embrace your IPv6 adoption, but be realistic. What are you really using? What is working in your backbone, and what do you really need? This is really important. And simplify your backbone. So single stack, IPv4 and IPv6 in the future. Consider a migration to ISIS and segment routing, and use BGP as much as possible. And forget we always done in that way, in this way, and start for requirement and not from technology. Okay, that's all. Question?
Yes, thanks.
Thank you.
Nicola.
I am absolutely out of my comfort zone, so I think it's clear. And also, it's my first public presentation in English, so thank you, Christian, for that.
You did great, Nicola. I think that people was waiting for the questions. So, Jorge.
How do you see vendors' adoption in SR-V6 support on the basics? I mean,
currently there is one vendor that is developing segment routing. I'm sorry, SR-V6. All the deploy is now from Huawei. So Huawei have a big involvement and a big interest in that, because they have special use case for that. So this is for in the Asian part we have big number, and it's something different. I saw also really good use case for SR-V6, but more I think in the data center area, where the problem, one of the problem, it's the boundary, because with MPLS you have a clear domain where it's your part and the other part, because with ipv6 you lose this information, so you need to enforce the border and control that. Maybe in data center where there is now the standard, it's almost VXLAN EVPN, but there is no traffic engineering capability, and we talk about large data centers, so hyperscaler or something like this. There is a requirement, for example, for egress engineering. This is the most important thing that this is required, and most of the time is directly controlled by the application. So this with segment routing, it's a good use case. So the application might encode directly the egress point or control the traffic inside the data center. So this is the control of the application, but this is a special case. Okay, so there are use cases for any protocol. So.
thank you very much for the presentation. It was very clear. Congratulations.
Thank you.
Last missing question for Nicola. You will have time to reach all the speakers during the coffee breaks. So we have now the last one.